Hello there, welcome to the October 2020 paper. Here we're looking at question 8. The temperature theta degrees Celsius of a cup of tea, t minutes after it was placed on a table in room temperature, is modelled by the equation theta equals 18 plus 65 e to the minus t over 8. According to the model, the temperature of the cup of tea, find the temperature, the cup of tea when it's placed on the table. That's effectively when t is equal to 0. So substituting t is equal to 0, and theta is going to equal 18 plus, now e to the power of 0 is 1, anything to the power of 0 is 1, so it's 18 plus 65, which is going to be equal to 83. Quite a hot cup of tea there. Part B, find the value of t to one decimal place when the temperature of the cup of tea was 35 degrees Celsius. Okay, so that's when theta equals 35. Let's put that into the equation. So it's 35 equals 18 plus 65 e to the minus t over 8. Let's move the 18 onto the other side first. So it would be 17 equals 65 e to the minus t over 8. Divide by the 65 onto the other side and you get 17 over 65 equals e to the minus t over 8. Now how do we get rid of the e? You ln both sides now, so it's going to be ln of the left hand side and ln of the right hand side. On the right hand side, that will just get rid of the e, so it's now minus t over 8. And now we need to do in the calculator ln fraction button 17 over 65, and that gives us minus 1.34, but we've got negatives on both sides, so we can just scribble both of them out, and times by 8, so I'm going to times by minus 8 on my calculator. That will get rid of the negative as well, so t equals 10.729 to one decimal place, so it's going to be t equals 10.7. Moving on to part C, explain why, according to this model, the temperature of the cup of tea will not fall below 15 degrees Celsius. The reason for this is because e to the power of anything, let's just put e to the power of x, is always positive, so therefore 65 e to the minus t over 8 is always going to be positive as well, so therefore 18 plus 65 e to the minus t over 8 is always going to be greater than 18, because we've just added 18 to both sides of this inequality here, so therefore 18 plus 65 e to the minus t over 8 is always over 15 degrees Celsius. It's always over 18 degrees Celsius, but definitely over 15 degrees Celsius. Okay, let's move on to part D now. So figure 2 shows a sketch of, let's start from the beginning. The temperature mu degrees Celsius of a second cup of tea, t minutes after it was placed on the table in a different room, is modelled by the equation of this expression here, where a and b are constants. Figure 2 shows a sketch of mu against t with two data points that lie on the curve. The line L, given in figure 2, is an asymptote to the curve. Using the equation of this model and the information given in figure 2, find the information of the asymptote L. So we know that when t equals 0, we have 94. So 94 equals a plus b. And we know also that when t equals 8, we get 50. So second equation is 50 equals a plus b, e to the minus 1. Because when t is 8, it's going to be 8 over 8, and then minus the 8 over 8, which is minus 1. So what we'll now do with these equations here is, I think if we label this one here as equation number 2, this one here is equation number 1, we'll do 1 take away 2. Solve these as simultaneous equations. The a's will cancel here. So 94 take away 50 is 44. And then on the b's, it's going to be b and then it's going to be 1 minus e to the minus 1. So let's now work this out then. So it's going to be 44, fraction button, 1 minus e to the minus 1, which is going to be 69.6. So therefore b equals 69.6. So therefore a is going to be 94 minus this value, 94 minus answer, which is 24.4. So therefore the equation of the asymptote L is going to be, well, actually a is just the asymptote of L, so therefore it's going to be y equals 24.4. That would be the lowest value. What will happen here is effectively as t gets bigger, this part of the expression here will tend towards 0, so it's just actually what we have remaining for a. In fact, maybe that's not the correct way of writing the equation, given that mu is on the y-axis, so maybe the equation should be mu equals 24.4. So there we are, that's the answer for this question here, 24.4 is the answer. And that's 9 marks there for question 8. Let's then move on to question 9.